Welcome to the Deep Dive. We're here to pull out the key knowledge from loads of sources just for you. Today, we're getting into something really fascinating. Forensic identity. Linking evidence to source. It's all about how forensic science can uncover stories from, well, even the tiniest little traces. So, our mission for this deep dive is to really unpack how experts figure out who or what was involved, just using these minute details left behind. It's this incredible mix of science and detective work. The big question we're tackling is, how do investigators actually connect a piece of evidence, any piece, back to where it came from?
Yeah, it all comes down to a core idea. Identification. It's this systematic process, The goal is to link an item of evidence, could be a person, an object, some material, back to one specific source. And we do that using two main concepts. There are class characteristics. These narrow things down to a group. And then there are individual characteristics. These are the unique link to just one source. Understanding that difference, well, it's fundamental to everything else.
Okay, let's unpack that. So when evidence turns up at a scene, how do forensic scientists even start trying to identify a person? Are we just looking for, obvious things, or are there sort of subtler ways our bodies leave a unique ID?
Well, the aim is always finding those markers that really set one person apart from everyone else. We often begin with biological stuff, traces, and also any physical marks someone might leave.
Can you give us some examples? What are we talking about here?
Absolutely. Take footprints, a bare footprint. Incredibly valuable. The ridges and furrows on the sole of your foot, they're unique, just like fingerprints. So those patterns, they're an individual characteristic. Shoe prints are a bit different, at least initially. They give us class characteristics, things like the brand, the size, maybe the shoe model.
Right.
But here's where it gets interesting. As you wear a shoe, it picks up unique wear patterns, little cuts, maybe tears, things embedded in the sole. Those details, they shift it from class to individual characteristics. That lets us potentially match it to one specific shoe.
Wow, okay. So something general becomes really specific over time. What about biological stuff like hair or skin or blood? DNA gets mentioned a lot. Is that still the main thing?
Oh, absolutely. These are prime sources for DNA, and DNA really is the gold standard for identifying an individual. Think of a DNA profile like a unique genetic blueprint. It's incredibly powerful. It can clear someone years later or connect cold cases. It's often the definitive link. Years ago, microscopic analysis of hair might just give class characteristics like color or where on the body it came from, and blood grouping, the ABO system, that only narrows down the possibilities. But getting DNA from those same samples now, that provides definite individual characteristics.
Right, that DNA specificity is key. So beyond the biologicals, what about other, maybe more unusual physical features, things people might not think about?
Well, fingerprints, of course. They're the classic example. Everyone knows about those. The friction ridge patterns are permanent and totally unique. That's crucial. But also, think about things like scars, tattoos, even birthmarks, anything that marks a body in a unique way. And for really tough cases, maybe decomposition or just skeletal remains, dental records are vital. Our teeth hold so much information. And forensic anthropologists can look at unique bone features too. Things like healed fractures or just odd bone structures. They compare those to records from before death, anti-mortem records to try and get an ID.
It's kind of amazing how much information our bodies carry, these hidden signatures. From your viewpoint, what's the most striking detail about how much we reveal without even realizing it?
For me, it's probably the microscopic level, like the unique way pores are arranged along just one ridge on your fingertip. It's so tiny, but it's distinctly you. And it's not just our bodies, The objects we interact with, they tell stories too.
That's a perfect transition. We've talked about identifying people. But what about objects? How can you identify an object, especially if it's, say, broken, or maybe it just left an impression behind?
Right. So here the process shifts to analyzing unique marks or impressions, shapes. Often things caused by tiny imperfections on the object itself or damage from use. We're looking for those unique signatures, again, just on objects this time. Identifying marks and impressions are really, really important here. When something hard hits a softer surface, it can leave an impression that mirrors its unique features. These can be flat, like a print that's two-dimensional, or they can have depth and indentation that's three-dimensional. This kind of analysis is just critical for looking at tool marks and also firearms.
Okay, so just like our feet wear down shoes, the shoes themselves develop unique features. That same principle applies.
Exactly. Yeah, let's flip it around. Think of the shoe itself as the object. Its tread pattern, the design, that starts as a class characteristic. Links it to maybe a Nike size 10, Air Max model, whatever. But as it's worn, it gets those individual characteristics. unique scuffs, wear patterns, maybe a stone stuck in a particular groove. These tell the shoe's life story, you could say, and allow for a positive match back to that one shoe.
That makes total sense. So do other tools work the same way? Like if someone uses a screwdriver or fires a gun, do they leave unique marks too?
Oh, absolutely. Almost any tool, screwdriver, pliers, wire cutters, even a firearm, it gets tiny, unique imperfections. Some from manufacturing, some just from being used, microscopic stuff. When that tool's used, say, to pry something open or cut something, these imperfections transfer. They create distinctive striations. Think of those as unique scratches, or impressions unique dents. So forensic examiners can compare a mark from a crime scene, maybe on a door frame, to test marks made by a suspect's screwdriver. And in ballistics, yes, definitely. A gun barrel leaves unique scratches, striations, on the bullet as it travels down. And the firing pin leaves a unique mark on the cartridge case when it strikes it. That allows a bullet or casing found at a scene to be linked back to a specific gun, often with very high certainty. But what I find really fascinating is how even something random, like something breaking, can tell a very specific story.
Right. That sounds like something you'd see on TV. You mean rupture or fracture marks? Fracture matching. Can they really piece something back together like a jigsaw puzzle and know for sure it's the original item?
Yes, exactly. It works because of a simple principle. No two things will ever break in precisely the same way. Ever. Think about a broken headlight lens or a piece of plastic trim from a car. The edges where it broke the shape, the texture, tiny little irregularities you can only see under a microscope, they're incredibly distinct. So if you find a fragment at a scene and you have a broken item from a suspect's car, you can physically fit them together. If they match perfectly along that unique fracture line, it's a conclusive link, like puzzle pieces.
Okay, so we've covered identifying people, identifying objects by shape and marks. What about identifying objects by what they're actually made of? Like getting into the chemistry of it all, the invisible stuff.
Precisely. Now we're talking about analyzing the intrinsic properties of a material, its fundamental makeup. To figure out its origin and maybe link it back to a source, it's about understanding the chemical composition, the elements involved.
So something common like paint chips. You find those a lot in hit and runs, right?
Paint is very common evidence, yeah. Hit and runs, burglaries, where maybe a tool scrapes some paint off. Analyzing paint is multi-step. First, you look at the physical properties. The color, the texture, crucially, the sequence of layers. Cars have multiple layers, primer, color, clear coat. Then comes the chemical analysis. We use sophisticated techniques like gas chromatography, mass spectrometry, GCMS, or infrared spectroscopy, IR. Think of these as ways to get a chemical fingerprint of the paint. They tell us about the binders, the pigments, the additives used. That chemical fingerprint can then be compared to a known paint source, like paint from a suspect vehicle.
That is an incredible level of detail from just a tiny chip. What about things like metals? Or even, say, pottery fragments? Similar idea.
Yes, very similar principle. Things like colored objects, metals, specific alloys, bits of chain, even earthenware or pottery shards. They can all be analyzed for their elemental and chemical composition. We might use something called scanning electron microscopy with energy dispersive X-ray spectroscopy, or SEM-EDX. It basically maps out what elements are present and in what amounts, almost like an elemental recipe. So the specific mix of metals in an alloy fragment or the minerals in a piece of pottery trace elements in colored glass. These can give us class characteristics at least, linking a sample to a known source, maybe a specific manufacturer or batch. Same idea for building materials, cement, plaster, bricks. Analyzing their composition might reveal unique additives or the type of sand used, maybe specific trace minerals. That could potentially link evidence back to a specific construction site or region.
Okay, this makes me wonder, how specific can something really common, like dirt, actually be? Soil, dust, it seems like it's everywhere.
You'd be genuinely surprised. Soil is incredibly complex. It's a mixture of minerals, organic stuff, water, air. And its composition can change dramatically, even just a few feet away. So forensic soil analysis looks at, well, the mineral content, the size of the particles, what kinds of pollen or fungi are in there, maybe even tiny manufactured particles. That unique combination acts almost like a location's fingerprint. So soil found on a shoe or in a tire tread could potentially link a person or vehicle to a very specific spot. And plastics, too. We can analyze the type of polymer, the additives using techniques like pyrolysis gas chromatography or PyGC. Plus, you can look at physical features on plastics, mold marks, scratches, stress lines that might link back to how it was made or a specific item.
Wow. So putting this all together, what does it mean for the bigger picture in an investigation? It's clearly more than just finding one matching clue, isn't it?
Oh, definitely. It means that forensic identification is this really rigorous, systematic process. It relies on both unique features and those common or class characteristics. By combining all these different techniques, physical examination, chemical analysis, biological analysis, forensic examiners build a scientific case. They establish a solid basis for linking evidence to a source. And it's not just about pointing fingers, it's about establishing the facts scientifically. It plays a critical role in getting to the truth.
That was an incredible journey into the sheer precision and depth of forensic science. It really is remarkable how everything, from a simple footprint to the chemistry of dust, can hold a unique signature, can tell a story that we wouldn't see otherwise.
Yeah, maybe think about this. Consider how many unique signatures you leave behind every single day, not just by what you do, but just through the materials you touch, you interact with. Every single object has a history, doesn't it? How it was made, how it was used, where it's been. Forensic science really is just the art of learning how to read those hidden stories.
A really thought-provoking way to end it. Thank you so much for joining us on this deep dive. We hope you, listening, start to notice some of those hidden details out there and the fascinating stories they might be telling.